Hello. Yes, we welcome you back to PSSB, Physical Sciences. Silver Bullet and Smith Richard here. Yes, we are looking at this question. It says that write the general formula of haloalkanes. Okay, what is the general formula of haloalkanes? It is CN H2N plus 1. Then comes the halogen, where X is that. Yeah, that is it. So comes this question. It says, write the structure formula of the functional group of haloalkanes. Okay, you have to know that haloalkanes simply consists of a halogen. So the structure formula is that X, where X stands for fluorine, chlorine, bromine, iodine atom. So comes this question. It says, consider the compounds below. Okay, we have the compounds A, B, C, and D. And it says, write the IUPAC name of each. Okay, let's look at A. Our A, it has the parent chain. It is shown. It is this one. And whatever is not part of the parent chain is a branch. So we have two branches. We have a methyl and a fluoride. And both of them, our branches are on position number 2. If you count from this side, this one is position number 2. If you count from this side, this one is position number 2. Under that circumstance where a halogen and alkyl group are having the same position, then you choose the one with which comes first in alphabetical order. And that implies that this is number 1, number 2, number 3, number 4. Why? Because fluorine is given the smallest number as it comes first in alphabetical order. So with that, what are you going to say? We are going to say the compound is 2 fluoro, 3 methyl, therefore, so it's a butane. So we go to B. And with B, you have a halide here, and you have the methyl groups there. And remember, the halide doesn't have any special entry compared to the methyl group. Though when we are naming, it must come first. So you have to choose the side which will give the total of these 3 the smallest number. And that side is going to be this one. So this is number 1, number 2, number 3, number 4. That will give you 2, 2, 3. Because when you start from this side, it's going to give you 3, okay, 2, 3, 3, which is bigger. So that is what we are having. And when you map out the parent chain, this is what we are having. And whatever is not part of that is a branch. So what are you going to say? We are going to say B is it is 3 chloro. Why? Because it comes first in alphabetical order, then 2, 2 dimethyl butane. Okay. Then we come to this one, the C. You have to choose the side which gives our functional group the smallest number, and that side is this one. So it's going to be 1, 2, 3, 4, 5. And what's going to be the name? The name is going to be 2 bromo pentane. Then you come to D. In D, this is what you have to know. You have to give our functional group the smallest number. But in this case, our functional group is in the middle, so you can choose either side. So if I choose this side, it's going to be 1, 2, 3, 4, 5. So it's going to be what? 3 bromo pentane. So that is what we have. So comes this question. It says, identify any two of the above which are positional isomers. Okay. What are those ones which are positional isomers? The answer is C and D. Remember, these have the same parent chain but different position of the halogen. Okay, then comes this question. It says, state whether the halogens above are saturated or unsaturated. Explain your answer. Okay, the answer is that they are saturated. Why? Yeah, the reason is that they do not have any multiple bond between carbon atoms. So that is that. They don't have any multiple bond between carbon atoms. Yeah, then comes this question. It says, consider the alkyl halides below. We have the A, B, and C. And it says, identify which of the above is a primary haloalkane and explain your answer. Okay, which one is a primary? Answer is A. A is the primary haloalkanes. Why? Because the carbon atom, this carbon atom on which our bromine is attached, it is attached to one alkyl group. I repeat, this carbon atom on which our halogen is attached to one alkyl group. So let's put that one down. Yeah, then comes this question. It says, identify which of the above is a secondary haloalkane and explain your answer. The answer is C. And why C? Okay, this is the reason. You see, this carbon atom is the one which is hosting our halide. And this carbon is attached to two alkyl groups. So that's the reason. The carbon atom on which the halogen is attached, it is attached to two alkyl groups. So that is that. The carbon atom on which the halogen is attached, it is attached to two alkyl groups. So then comes this one. It says that identify which of the above is a tertiary haloalkanes. Okay, the answer is B. Why? Okay, let's look at B. This is the carbon atom on which our halogen is attached. And when you examine it, you are going to find out that it is attached to three alkyl groups. And that's what makes it to be a tertiary. So that is that. And with that, we would like to thank you for your time. The channel is PSSB. We urge you to subscribe, to like, to comment, to share. Yes, we believe we are simply the best. See you next time. Bye bye.